Welcome to ConsumerTimes. Are you being charged correctly for your electricity? Understanding energy meter testing and calibration is crucial for every consumer and professional. In this comprehensive ConsumerTimes episode, we dive deep into the world of energy meter testing, calibration procedures, and international standards that protect your rights as a consumer. Hello and welcome back to ConsumerTimes. I'm your name, and today we are discussing a topic that directly impacts your wallet every single month: energy meter testing and calibration. Whether you are a homeowner concerned about accurate billing, an electrical professional, or just someone who wants to understand how electricity metering works, this video is for you. So let's dive in. An energy meter, also known as an electricity meter or watt-hour meter, is a device that measures the amount of electrical energy consumed by your home or business. Think of it as the bridge between the power company and your monthly bill. Every kilowatt hour that passes through this meter gets added to your bill. Now imagine if this meter is inaccurate, you could be paying more than you actually consume, or in some cases, paying less, which creates issues for the power distribution system. This is exactly why energy meter testing and calibration are absolutely critical. Testing ensures that the meter is measuring accurately, while calibration is the process of adjusting the meter to meet specific accuracy standards. Without proper testing and calibration, you cannot trust the readings, and that's where international standards come into play. Energy meters worldwide are governed by strict international standards to ensure uniformity, accuracy, and consumer protection. The most widely recognized standards come from the International Electrotechnical Commission, or IEC. The primary standards for energy meters are IEC 62052 and IEC 62053 series. IEC 62052 provides the general requirements for electricity metering equipment, covering aspects like terminology, testing methods, and performance specifications. The IEC 62053 series specifically addresses particular requirements for different types of meters: static meters for active energy, reactive energy, and multifunction meters. In India, we follow the Bureau of Indian Standards specifications, particularly IS 13779 for alternating current static watt-hour meters and IS 16444 for electronic meters with additional functionalities. These Indian standards are harmonized with IEC standards to maintain global compatibility. In North America, the American National Standards Institute standard ANSI C12.20 governs revenue metering, providing specifications for accuracy classes and testing procedures. These standards aren't just technical documents, they're your protection as a consumer. They define exactly how accurate a meter must be, how it should be tested, and what tolerances are acceptable. Before we discuss testing, let's understand the types of meters currently in use. Traditional electromechanical meters, often called analog meters, use rotating discs and are becoming obsolete but still exist in many areas. These meters measure energy through electromagnetic induction. Then we have electronic or static meters, which use digital technology and have no moving parts. These are more accurate and can measure multiple parameters. Finally, smart meters represent the latest generation. They're electronic meters with communication capabilities that can send real-time data to the utility company and even allow remote disconnection and reconnection. Each type requires different testing methodologies, but the fundamental principle remains the same: ensuring measurement accuracy. Energy meters are classified based on their accuracy. According to IEC standards, meters are designated with accuracy classes like Class 1, Class 2, or more precisely, Class 0.2s, 0.5s, 1.0, or 2.0. The number represents the maximum permissible error as a percentage of the measured value. For example, a Class 1 meter can have a maximum error of plus or minus 1% within the specified load range. For residential applications, Class 1 or Class 2 meters are typically used. Industrial and commercial applications, where accurate billing of large amounts of energy is critical, may require Class 0.5s or even higher accuracy meters. These accuracy requirements must be maintained throughout the meter's operational life, which is typically 15 to 20 years for modern electronic meters. This is where periodic testing and calibration become essential. Energy meter testing is a systematic process conducted in specialized laboratories equipped with precision instruments. The testing typically involves several key stages. First is visual inspection, where the meter is examined for physical damage, tampering, or deterioration of components. Any signs of damage can affect accuracy and must be documented. Next comes the actual accuracy testing. The meter is connected to a reference standard meter, which is a highly accurate meter calibrated against national or international standards. Both meters are subjected to identical electrical loads, and their readings are compared. Testing is performed at various load levels, typically at 10%, 50%, and 100% of the rated load, because meter accuracy can vary across different load conditions. Power factor is also varied during testing because it affects how meters measure energy in alternating current systems. For single-phase meters, testing might take 2 to 3 hours, while three-phase meters require more comprehensive testing that can take 4 to 6 hours. During testing, parameters like voltage, current, power factor, frequency, and temperature are carefully. If testing reveals that a meter's error exceeds the permissible limits defined by standards, calibration becomes necessary. Calibration involves adjusting internal components or software parameters to bring the meter back within acceptable accuracy limits. For electronic meters, this often involves adjusting calibration constants stored in the meter's memory. The process requires specialized equipment called meter test benches or calibration systems, which can generate precise voltage and current signals. Modern calibration systems are computer controlled and can automatically perform tests at multiple load points, calculate errors, and even adjust the meter if it's electronically calibratable. After calibration, the meter must be retested to verify that it now meets accuracy requirements. A calibration certificate is then issued, documenting the date, results, standards used, and the validity period of the calibration. It's important to note that the testing equipment itself must be calibrated and traceable to national or international standards. In most countries, the National Metrology Institute maintains primary standards for electrical measurements. Testing laboratories must have their reference standards calibrated by these institutes or by accredited calibration labs. This creates a chain of traceability that ensures every energy meter in the field is ultimately referenced to the same fundamental standards. As a consumer, you have the right to request meter testing if you suspect your bill is incorrect. Most utility companies have procedures for this. In India, electricity distribution companies are required to test meters periodically as per State Electricity Regulatory Commission guidelines. Typically, meters are tested every 5 to 10 years depending on the type and regulations. If you believe your meter is faulty, you can file a complaint with your electricity provider. They're obligated to test the meter, usually within a specified time frame, often 30 days. If the meter is found to be reading high, you are entitled to bill-in corrections. However, if the meter is accurate, you might be charged a testing fee in some jurisdictions. Several factors can cause meter inaccuracy. Voltage fluctuations beyond the meter's design range can affect electronic meters. Extreme temperatures, especially heat, can degrade components over time. Tampering is unfortunately common and can cause meters to under-register or stop working altogether. Poor installation, loose connections, or corroded terminals can also lead to measurement errors. In electromechanical meters, worn bearings or accumulated dust on the disc can cause errors, Smart meters are revolutionizing energy metering, and testing procedures are evolving accordingly. These meters not only measure energy but also record time of use data, detect power quality issues, and communicate remotely. Testing smart meters involves verifying not just measurement accuracy but also communication protocols, security features, and data integrity. Standards are continuously being updated to address these new requirements. Energy meter testing and calibration based on international standards is not just a technical necessity, it's a consumer protection mechanism. Whether you are paying a residential electricity bill or managing a large industrial facility, accurate metering ensures fair billing and efficient energy management. Understanding these standards empowers you to question discrepancies and demand accurate metering. If you found this information valuable, please like this video, share it with others who might benefit, and subscribe to ConsumerTimes for more content that helps you make informed decisions. Drop your questions in the comments below. Have you ever had your meter tested? What was your experience? Let's start a conversation. Until next time, stay informed and stay empowered. Thank you for watching.